Hello, everybody. Thank you for joining me today. Hope you've been having a great time at today's Government Mobility Conference. My name is Bryan Zanoli. I'm a virtualization consultant with Entisys Solutions. And today I'm going to be discussing how we can mobilize Windows applications and desktops on non-Windows platforms, and pretty much going to talk about mobility in general. First, I'd like to share a big secret with you. And that is, virtual desktop infrastructure is easy to do. All right, so we're going to get these desktops on these non-Windows devices. Super easy to do this incorrectly. I'm going to show you how I can set it up in 4 easy steps and have a virtual desktop infrastructure ready to go. First, we're going to start with our hypervisor here. After all, it is virtual desktop infrastructure. I'm going to deploy a VM. I'm going to install Windows 7 in this VM. Get it prepared the way you normally would. And then on my mobile device, I'm going to set up a VPN connection into our data center. If you're using iOS or Android, this is all built in as it comes within the software. I get it connected up. So now I'm connected to our internal network. I've got to find some way to connect, so I'm going to use RDP. I'll download Microsoft's RD client. And I've got everything I need. Launch the application, type in my virtual machine name, and there you go. Just like that. Super simple, right? Except it seems like it's missing something. There's just not enough there. And what's missing from this easy solution? Well, it doesn't have any agility. If we want to spawn up new VMs, sure, we could use templates, VM templates to do that, but if you've ever spawned up a large number of VMs from a single template, it puts tremendous strain on your infrastructure resources. Scalability? Well, let's just look at the storage aspect of that. If you're talking about 30 gigabytes, just a 30 gigabyte hard drive for each desktop, that's about 150 terabytes and 130,000 IOPS in a 5,000 user deployment. It's a lot of storage, so it doesn't scale out very well. Control? Well, with what we set up here, there really isn't any. We have no way of assigning users to desktops, no way of controlling any kind of desktop policies. And finally, security. We just gave our users and their devices complete access into our data center. That doesn't seem like the ideal way to do this, and it's not. So we'll jump back into VDI in a minute, but first, let's define the mobile workforce. So what is it? It's anywhere access on any kind of device, giving your users a ubiquitous user experience, so a consistent experience no matter where they're connecting from. It's giving us increased collaboration, increased productivity, and increased efficiencies. And then how about the infrastructure side? What does it look like? What components are necessary? We're looking at applications and desktops, a way to personalize and manage user data and settings, and then a way to manage devices, deploy applications, and finally, some method of access for our users that is secure and easy to use. So jumping in back into virtual desktop infrastructure, how do we plan this out? What are some of the considerations that we have to take in mind when we're going down the road of deploying virtual desktop infrastructure? First of all, persistent versus non-persistent. There's a big debate about how we're going to approach storage of user data and the allocation of applications, whether we want that to be saved or discarded. And that's going to drive how you approach your VDI deployment. Next, we're looking at virtual desktop sizing. How much resources are we going to give based on compute, RAM, and most importantly, storage to each user? Network and remote access, what kind of optimizations are we going to have in place to make sure that the users receive the kind of connection that they're looking for, the quality that they're looking for in their applications? Are we going to give them remote access? How are we going to secure that? Or are we going to restrict it so that it's only internal? And then finally, we're going to want to analyze our server resources and user densities to ensure that we've got enough to scale out and to scale up. So let's look at a few of the architectures of the 3 main vendors involved in the VDI space. So we'll start here with VMware View. Now, all three of these are going to be very similar, so as I'm going through them, take note of some of the similarities between the three. You'll see that the architectures share a lot of commonalities. So first, VMware View is deployed exclusively on the vSphere hypervisor. We're going to manage our VMware View environment using the VMware View Manager or connection server, and that's where we're going to take care of user authentication. We're going to assign users to their desktops. And then next on this list here, we've got our VMware View Composer. And what that's for is to spawn up the additional desktops that we're going to want to have these users log into, and a method that's quick and agile. Also shown here on this slide is a VMware ThinApp, and that's VMware's application virtualization technology. And you can see that we can connect then from our various clients using VMware's PCOIP protocol. Although it may look a little different here, a similar architecture for Citrix's Zen Desktop, a platform that can be deployed onto VMware vSphere, Microsoft Hyper-V, or Citrix Zen Server. You've got similar components here, and the delivery controller is what's going to be used as the management server. This is also responsible for user assignments, as well as any policies that you would like to enforce in your Zen Desktop environment. You've got your storefront server, which serves as a portal or interface into the virtual desktops, and the receiver, which is the client that's installed on the client side. Also shown here is Studio, which is going to manage your Zen Desktop environment, and the Citrix Director, which is an optional but suggested component used to analyze and troubleshoot your Zen Desktop environment. Lastly, we've got Microsoft, who has their own out-of-the-box solution for remote for desktop virtualization using their remote desktop services. Similar to the previous two solutions, you've got a remote desktop connection broker, which is their management server. You've got a remote desktop gateway, which serves as Microsoft's secure access into your virtual desktop infrastructure. And you've got a remote desktop web access server, which is responsible for, to serve as a portal to the users to be able to log in and access their desktops. Now you'll notice that on all the previous two slides, you have the ability to install not just on desktops, but on servers. And that will become important later when we're talking about published applications. For now, let's look at a few of the hardware enhancements that have come about recently that have made VDI a little bit more feasible from a deployment and cost perspective. First, let's look at storage, since after all, it's one of the biggest resources required for a successful deployment. What are some of the enhancements that have come about recently? We're looking at all-flash arrays to accommodate the level of IOPS necessary to support your user base. Software-defined storage, which allows you to leverage different types of storage platforms as well as local storage, and even hybridize spinning and flash disks. Deduplication, which can take the total amount of capacity that is necessary and reduce that. And then hyper-converged solutions such as GridStore and Nutanix, which allow you to consolidate compute and storage resources into one platform. Next, for the graphic-intensive applications, something that really wasn't possible to be virtualized up until a few years ago, we've had significant improvements in the GPU virtualization field with the advent of NVIDIA Grid. NVIDIA Grid allows you to actually virtualize and carve up additional GPU resources per desktop based on whatever resources you need, whether it's just light graphics in the case of something like Photoshop or GIS applications, or it's extremely intensive applications such as large 3D models that are being rendered. Finally, and a pretty significant hardware-based advancement, HP has just recently released their Moonshot platform. And what this does is allows you to, rather than using just straight virtual resources, kind of goes back into the hardware-based resources. Each user gets their own designated node within a cartridge, and you can have 4 nodes per cartridge, 45 cartridge per chassis. So you can increase user densities while also simultaneously increasing the amount of resources dedicated to each user. And if you're looking for a kind of transition solution, something like Citrix's Remote PC allows you to install their virtual desktop agent, something that's normally installed in the virtual desktop itself. You can install that onto any workstation. So this could be their existing workstation that they already have under their desk currently. And this allows you to get in the door with the VDI platform, but use your existing physical resources. So now that we've architected our solution and we've reviewed some of the enhancements to the hardware side, let's look at managing VDI images. So we referenced View Composer and what that's used for. So we're going to talk real quick about VMware's linked clones and how this works. So first, we're going to start off with a master VM. This is where you have all of your applications installed, any customizations performed on the OS. We're going to take a snapshot of this VM, and we're going to deploy a replica. Now, VMware's doing this all in the background for you, so you really don't have to control any of this. With this replica, VMware's going to spin up additional linked clone VMs, and they're going to deploy, for each linked clone, an OS Delta disk to track changes, an internal disk, which is going to store all of your computer name and password information, an optional persistent disk so that your changes can be, of course, persistent over reboots, and also optional a disposable disk that would be used to store your page file or any other dynamic files that would cause the Delta disk to grow extraneously. Moving on to the 2 methods through Citrix. First, the machine creation services. So this is going to be something that's very similar to VMware's linked clones, in that it deploys from a base disk using a master VM. On the other hand, provisioning services is a separate infrastructure component that allows you to stream your images over the network from a single server or a single service. So what this means is you get features such as the ability to cache that image in RAM, the ability to deploy that image to VMs that are using RAM cache for writes. Essentially, the general rule of thumb here is if you're going to do a small deployment and you want it to be quick and easy, go with machine creation services. If you're going to scale out, provisioning services is the way to go. So for large deployments in which you're trying to put less I/O on your storage infrastructure, provisioning services offer tremendous benefits over MCS, though both are great solutions. So we've taken care of our images. How about the user profiles? We've got to find a way to take care of those profiles, especially if we're in a non-persistent VM that doesn't save those settings every time you reboot. Well, we could go local and just give each user a dedicated VM, which does store all of your persistent changes. But that's not always necessarily the best way, especially if we're trying to give a consistent user experience no matter where they log into or from. So for remote or roaming, we could start just out of the box with Microsoft's roaming profiles, though it's pretty basic and just stores all of your user settings and data on a share somewhere. Stepping up from that, you have VMware's Persona Management and Citrix's User Profile Manager, which offer additional benefits such as the ability to stream profiles, which means you can actually download just the files and settings that are in the profile as they're needed rather than all at once during logon. And then if you're looking to expand your profile management solution, both Absence and Res are great examples of solutions that take it a bit further. enabling support for cross-platform user profiles. So whether a user logs in from a Windows 7 machine or a Windows 8 machine, they'll get the same settings on all their applications. So we already discussed briefly persistent and non-persistent and what that means. And since it is such a big deal, and whether you decide to go persistent or non-persistent is so pivotal into the kind of components and the kind of virtual desktop planning that you're going to do, let's talk about the pros and cons of each. So first, pros of persistent desktops. Well, this is kind of like the way you have it deployed currently in your existing infrastructure, in which each user gets their own desktop. It's just instead of being at their desk, this is in the data center. So the way that you're currently managing those desktops is essentially going to be the same thing. Users can install applications, users can save settings, save data just on the local desktop. Everything is as they expect it to be. Unfortunately, there are some serious cons to persistent desktops. The first one being, you're going to be spending a lot of money on storage to support this, so your storage vendor is going to be really happy. And then, yes, we are using the same management tools, but we have this ability to deploy individual or images that represent all of your desktops, and yet we're managing each desktop individually. And then, since users do have that ability to modify their own desktop, just like they can now, they can destroy their own desktops, causing you to have to frequently reload, reset everything, and copy in some settings, assist them with the reinstalling applications. So it brings us to non-persistent desktops. Since we're going with a provisioning method that allows us to share the base image or base disk, we don't need 30 gigabytes per user. Maybe we only need 4 or 5 gigabytes per user. Now, instead of installing applications and updates on each individual VM, we're installing applications and updates onto a single one and quickly rolling that out to all desktops. And then, if a user does accidentally delete a file, uninstall an application, cause any kind of system corruption, you reboot it and it's back to the way it was. Sounds perfect, doesn't it? Like everything's grand. Problem is there is a downside to non-persistent desktops, and that's because you're using a single base disk in the case of either provisioning or machine creation services or linked clones, all of your read I/O is going to a single master VM, replica disk. So you do have to have greater control over where your I/O is coming from. You do have to become more familiar with the new imaging techniques. You can't just simply use System Center Configuration Manager to install additional applications on your image. And your users don't get to install any of their own applications. So you really want to weigh the pros and cons of each before you go down either path, because it's, as I've said a couple times now, it's going to greatly affect the outcome of your virtual desktop deployment. And what's important with everything that I've covered in virtual desktop infrastructure, it applies not just to users accessing it from desktops that are part of the organization or users that are connecting from home using their laptops or desktops. The same principles apply if you're doing a deployment for the use of deploying desktops to mobile devices. But then, are desktops the only way? Are they the absolute best way and best solution in all cases? I think we can restructure the way that we're looking at the desktop as something that simply hosts applications and user data, and instead of calling it a desktop or an operating system, we just say it's the user environment. All that we really care about are the applications and data that are running in the environment. So what are a few of the solutions that we have to accomplish this? We've got application publishing and virtualization. We're going to use mobile device management to control the devices, of course, as well as possibly deploy additional software. Application wrapping and other solutions through enterprise mobile application management. And in the case of data, we're going to use a solution for sharing and synchronizing and connecting into your data in the data center. So let's jump right into application publishing. So this is going to be similar to a deployment of virtual desktop infrastructure. Right? It uses all of the same components. And instead of using a desktop OS, it uses a server OS. You can install multiple applications onto the server and then publish it out to your mobile devices in a way that's seamless to the user. Now, it's easy to deploy. You can use the same profile management solution you use with virtual desktops. You're going to get much higher densities using published applications over virtual desktops. So you do have significant resource cost savings there. But unfortunately, just like desktops, if these applications are designed exclusively for a large format OS, you may run into some of the same formatting problems that you do with running a virtual desktop on, say, like a mobile phone, for example. You have to make sure that these applications are compatible. So if they are, if they're not multi-session compatible, or if you're looking to install applications that, say, ran in Windows 2000, it's not necessarily going to work in a Server 2008 R2 or 2012 R2 infrastructure. The other thing is if you're running very, very resource-intensive applications, once again back to the CAD drawings, or some heavy workload users in Photoshop, this may not always meet the demands of the users. A couple of other things about application publishing. You do need remote desktop licensing because it does all three solutions, whether it's through VMware Horizon 6, Citrix XenApp, or Microsoft Remote App. All three work off of the Remote Desktop Services platform. So what does the architecture look like for application publishing? Like I said, very similar to what you're seeing with virtual desktop infrastructure. You've got the management server, the session controller. You've got your session hosts, just like the virtual desktops. You're, of course, using authentication and storing your profiles on a separate file share. And then you've got some access mechanism, either a gateway or a web portal. And so I'd like to show you what each one looks like to the user when they log in. Looks very similar to an enterprise application store. So just with published applications, we're starting the creation of an enterprise app store for your users that they can access from any device. This here is Microsoft Remote App. We have VMware View and Citrix XenApp. So what about those cases where these applications aren't compatible? There is one step that we can make, and that is application virtualization, in which we're going to take this application, put it inside its own little sandbox, provide the resources, settings, and files that it needs to run, but run so that it thinks it's running by itself. Right? And this is going to more or less improve security because the operating system is being translated into the application, and you're going to be able to run multiple applications that otherwise may conflict in a different environment. So the architecture of any application virtualization solution relies on two main components: isolation and redirection, and then a delivery mechanism of some kind giving the user access to that application. In terms of isolation and redirection, all you're looking at is isolating the application's environment from the rest of the operating system. And redirection just tells the application to store whatever files or changes that are made to an alternate location. With the delivery mechanism, that is what we're very concerned with, because there are two types of delivery mechanisms that are commonly used, and that is you can either stream the application or you can access it remotely. If you're going to stream the application, it does have to be delivered to a Windows operating system. However, if we leverage our existing application publishing environments, we can simply have that run from the server and then present that application to the user. An excellent use case of application virtualization would be environments in which you're trying to run multiple applications running distinct versions of Java, where each application is only compatible with that version of Java. Obviously, we can't have 8 different versions of Java running on the same server, so instead, we could wrap these applications with the settings and resources that they need, and rather than managing 8 different images for these applications, we're consolidating them onto one. So these solutions so far, virtual desktop infrastructure, application publishing, and application virtualization, have been ideal not just for mobility, but also for your standard laptops and desktops. But let's get into solutions that specifically look at the mobile devices and how we deploy applications and data to those devices. As a quick overview of the architecture involved in any mobile services deployment, we're going to start with our enterprise core services. Of course, this is what we're trying to give users access to. And this illustrates that we're not just looking at stuff that's within our data center, but of course, services that may reside on the cloud as well. Our enterprise mobile services, the list of which includes an application manager, which we'll go over the purpose of that for soon here, an enterprise application store, which can be exactly what we presented with the application publishing, something very similar to that, a mobile device manager to implement policies, organizational specific, and then of course some kind of authentication mechanism. And finally, we're going to want to make sure that those users access both internal resources and cloud-based resources securely. So let's start with mobile device management. This is something that's been around actually for quite a while, kind of made popular with BlackBerry, the ability to control corporate-owned as well as user devices using policies that are sent out to the mobile devices. And these policies can contain items such as network restrictions, what networks the users do and do not have access to. You can whitelist and blacklist applications. You can then remote wipe certain devices if they're lost or stolen. And you can also implement things such as geofencing, authentication, PIN code requirements, and you can use your mobile device management solution to also deploy company-required software. But by itself, mobile device management doesn't accomplish everything. Most users are used to having some semblance of control over their devices. So especially in the case of BYOD scenario, if you're telling users, we're going to manage your device and we're going to restrict everything that you can run, and only under very strict guidelines are you allowed to install your own applications or use it for your own personal needs, that's not going to work very well. We're going to set all of these policies, and then users are just going to come around. They're going to send data to their own devices. Maybe they're going to attach a file that they're working on to an email and send it to their Google account instead of to their organization's account. They're going to use their own apps instead whenever they can, such as putting their data on Dropbox instead of using your data sharing solution. And worst case, they're just going to avoid putting data in enterprise apps altogether, which means you don't have the data that you need for your organization to be successful. So there is something that comes to the rescue, and that is application wrapping, available through mobile application management. What that's going to allow us to do is, rather than trying to secure the individual, the whole device by itself, we can just secure the individual application. And this is kind of an idea of why control the device when we can control our corporate application. So how does it work? Well, the application is wrapped on your mobile application management solution. We build in encryption. We build in our authentication and authorization policies. Any single sign-on services that we're going to want to use for the users to be able to just log right into the application's login. We make sure that the data is stored and and an encrypted shell, and we leverage a secure VPN that's tied to the application or to the container itself, not just to the device. So we secure that application's communication with your data center, and we don't let the device itself have access to your data center. We can also set specific application policies which may or may not allow this application to interact with other applications on the device. Maybe you can't cut and paste from one location to the other. So how does this look on the user's device? Well, we have our secure container. We have our corporate applications. They're using encrypted data that is stored within the shell, and then they either all or individually have access to your data center via the secure VPN. You'll see here on the right that the personal apps are still there. They're storing on any kind of data. It doesn't really matter because that's not what we're concerned with, because this is the user information. And this is beneficial because if we were going to go back and do any kind of remote wipe of the user's device, let's say that they moved on to another organization, we need to make sure that that device is clean. Rather than wiping everything off of that device, including the user's photos and MP3s, all we do is take care of the secure container, all the corporate-owned data is removed, all of the applications are removed, and they still have access to everything personal. So we've got the applications on the device, but what about the data? So what we want to do is we want to go with a solution that offers us the ability to leverage the data that's already in the data center. We want to use data that's also in the cloud, maybe files that are on SharePoint, and we want to do that in a way that's secure. So most of these solutions, these are the top 4 solutions by Gartner, use very similar methodologies. They give you access to a wide variety of different types of files and file services, and they each approach it a little differently. For example, Box is predominantly in the cloud, Excellion is predominantly on-prem, and ShareFile kind of leverages a hybrid approach, which puts the authentication in the cloud but keeps all of your data on-prem, so you know that it's secured. And we want to approach the way that we're sharing and synchronizing our data in much the same way that we're approaching application management. We want to make sure that the data is stored on the device in a way that is encrypted. We don't want to give the enterprise file syncing and sharing solution access to our data center outside of just what's necessary. We also want to make sure that we set policies so that the right kind of data is accessible by the right applications and the right users, so that we hide sensitive data from users that shouldn't be able to access it remotely. So if we dive a little bit deeper into how we're going to secure our mobile environment, you can see that a lot of the solutions that we've gone over are going to pretty much accomplish most of these threats. Whether it's insecure configuration or a vulnerable OS, we have mobile device management to make sure that the device meets a certain minimum requirement in terms of the OS version. If it's unauthorized access, we can set a PIN. We can store the data in a way that's encrypted on the device. With virus and malware, if we use containers on that device, the virus is only going to have access to the personal container and is not going to be able to break through to the enterprise side. And then, of course, we've taken care of the device and we've secured the device, but we still have the question of how do we secure the infrastructure? Because just because the device has a larger threat zone than your infrastructure doesn't mean you still don't need to pay attention to the quality of the application in your infrastructure. If you are deploying applications in-house, you want to make sure that those applications are properly vetted before they're accessible externally. You do want to run routine malware checks and integrity checks just to make sure that you aren't being compromised. And of course, putting all your entire infrastructure behind some kind of secured gateway is absolutely crucial to maintaining a secure environment. So when we're looking at this, what's the right answer? How do we properly deploy a mobile device strategy or a mobile application strategy and deliver apps and desktops to our mobile workforce? The answer is, it depends, right? It matters tremendously on what it is that you're trying to accomplish, but as general guidelines, it's good to start with application publishing. It accomplishes the biggest bang for the buck, allows you to deliver applications not just to mobile devices, but to desktops and laptops as well. We're going to deploy VDI for the right workloads, those resource-hungry workloads that really demand the additional resources required. We're going to use application virtualization in those niche cases. I didn't mention it before, but application virtualization it can be a pretty complicated solution. You do have to make sure that that application has all of the right resources, all of the right settings configured so that at launch time when it's running, it doesn't need to reach outside of the isolation environment in order to access important registry settings, additional applications, or data. So we're going to use application virtualization somewhat sparingly to accomplish those necessary tasks. So we're going to leverage mobile application management and application wrapping for any in-house mobility applications or applications that are available, say through SaaS applications, for example. We're going to use MDM either with organizational owned devices or if additional security is required on BYOD. This would be extremely important in, say, healthcare or finance, where just because a user brings their own device and just because we're wrapping the application and securing the application doesn't mean that we don't want that added layer of security. And then finally, to give users access to the data that they need, we're going to incorporate an enterprise file syncing and sharing solution that can be deployed to any device and ensures that that data is accessible by the right applications and is stored so that it is secure at rest and in motion. So what does our fully integrated mobility architecture look like? Well, we'll see that we're able to combine a lot of the components into a single approach to managing both Windows applications and desktops on the Windows OS, as well as deploying it to the mobile OS. If a user is logging in, excuse me. So if the user is logging in from their laptop or desktop, they'll connect into the intelligent gateway here. And we're going to provide them with access to virtual published application workloads and virtual desktop workloads. We're going to use our application packager for virtual applications, virtualized applications presented through our session host. The user is going to connect through a web interface in order to launch the right applications and desktops, which is going to be brokered through some kind of management server. We're going to use an authentication mechanism, whether it be AD or dual factor with, say, RSA tokens. We're going to use file services to store user profiles and local data. We're going to use a storage controller leveraged by our enterprise file syncing and sharing solution that's going to connect to our backend file services, as well as any other data management solution that we have, such as SharePoint. So all of that is going to be used by our laptops and our desktops, but we can also deliver all of that through an enterprise application store to our mobile devices as well, our Android and iOS mobile phones and tablets. In this case, we'll add to this resources that are already available to your mobile devices. We'll add wrapped applications, present that to our enterprise application store. We'll manage our devices, which will allow us to enforce those mobile device policies, as well as push out wrapped applications and cloud service, software as a service applications. Again, with our mobile devices here, we're going to leverage an authentication mechanism that's utilized with our gateway, and we're going to present them with enterprise file syncing and sharing solution that gives them access to their data, whether it be on-prem file services or cloud-based file services. So as you can see, we can consolidate the entire architecture of VDI, published applications, and enterprise mobility management in a way that allows us to deliver on that promise to give users access to any applications from any device, anywhere. All right. Thank you, guys. Do you have any questions? No? All right. Well, if you do want to chat, Entisys does have a booth out on the trade show floor. You can follow me on Twitter or send me an email directly. Thanks again for coming.